All right, there we go. All right, now we're recording now. So, yeah, microservice architecture overview, API gateway. We're going to start looking at assignment 2, and we'll do some breakouts for assignment 1C, and we'll be able to answer any questions around that. So that's what we have planned today. If you guys do have any questions, please let me know. It is really important that you understand microservice architecture and how it differs from monolithic. This will be on the next exam, guaranteed. Guaranteed. And you do need to understand it because this is how we're going to be doing the coding for assignment 2 and 3. All right. So if we look at a basic, a simple microservice architecture, there are others out there, but almost all of them fit this standard form. I've got an API gateway. I've got my individual services, my individual microservices, and I have some kind of service registry. Okay. We're going to go really in depth on an API gateway. But before I do, can anyone tell me what the importance of an API gateway would be just by looking at the diagram? Give me some thoughts on what you guys think an API gateway would be used for.
Routing requests.
Yeah, routing requests. Good one, Ronald. Anyone else? What's the benefits?
Load balance.
Load balance. They can put a load balancer in there. Yep, that's one trick. Anyone else?
Does it improve security at all?
It does. There's some things I can put in the API gateway to improve security. We'll talk about exactly why. Anyone? No other ideas? What about one of the key fundamentals of software engineering and coupling? It decouples the client, which sits on the left. It decouples the client from the back-end architecture, which is really kind of nice. I can say it also provides a way that I can easily scale up, and I can change the back-end microservice architecture without affecting the client at all, which is actually pretty cool. All right, let's go over a little bit more on what the API gateway does. So the number one thing that you can think of in an API gateway, and the reason they were originally created for these multiple services, was that it provided a unified experience to the user or the client. So I can have the client sitting there and only talking to the API gateway, and then it doesn't matter what's happening on the back end because I'm only going through that gateway. Now, it can also mean that that gateway now becomes a single point of failure, right? Which, oh, well, if my API gateway goes down, then what happens? No one can talk to the microservices on the back end. So having a very robust and reliable API gateway is extremely important. Extremely important that is rock solid. Now, most of the time, API gateways have redundancy built in, and there'll be a small router or load balancer in the front of those, believe it or not, right? Or there's different techniques that they use to keep those API gateways up and running. But if it goes down, we've got a problem. But the benefits outweigh the risks in that this client now only talks to the API gateway, and the backend stuff can change as I need it to change, especially if I've got applications that are changing over time and dynamic, which happens quite a bit in our industry. Okay, so the next thing, and the way to look at it is this. So because the API gateway takes all of the API requests coming in, I have to take those API requests and route them to the appropriate microservice. So if I look at it in the basic terms, let's say that I've got a quote system here, And I got Handy Quote and Zippy Quote. Those are my two quote. And I can get a quote from Handy or I can get a quote from Zippy. When I hit the API gateway with that, it takes that URI that I send in and it says, oh, I know Handy Get Quote actually goes to service A. And I know that service A is at 192.168.0.10. Right? And I made a mistake there. That should be 0.11 or 12 on that bottom one, a different IP address, right? And I'm going to call get quote on that server and on that port, and it's going to end up going to that service that I wrote. So your API gateway does this mapping or routing based off of the API request that comes in. Okay, that's critical. And if you look at it, that's the basic thing that it does. Okay, so there's some other things that it can do. Well, the first thing it needs to be able to do is determine, given a URI that comes in, how do I map that to an IP address and a port and a full URL path in there. So I have to have something inside that API gateway. How would you guys guess that that is implemented inside an API gateway? Any ideas? How would you implement an API gateway if you built one yourself?
You would want to you would want to see what the source of the request to see the route of the originator, basically the refer. And then once you get the refer, you would probably have like an object of maps or a map that maps to different routes. And then based on that, based on basically like a regular expression or a matcher, you would kind of point it to the corresponding service.
Yeah.
And then you'd probably have some other things like authentication or something to validate that they can actually access it.
That they can actually access it.
Yeah.
Yeah, that's exactly right. Inside an API gateway, I can put authentication, I can put authorization in there, I can put security in there, so that when someone hits that API gateway, I now have all that built in. And then Hamza was right. There's typically a map in there, a very simple map. API gateways, there's a lot of really cool things I can do in there, and they're pretty lightweight and small. So they don't take up a lot of memory. And I want them to be as fast as possible to decrease any kind of overhead that I want. So a simple map is the simplest way to go. And I can map, the requests that come into the individual IP address port that I need. So it's pretty simple. Okay. So the other thing that's interesting about an API gateway is it only establishes the connection. It stays out of the way once you do the request. So any response back is going to go directly back to the client, not back through the gateway. So it routes the request to the designated backend server. It forwards the request on there, and then it can answer back. So that service A is not going back to the gateway. It's actually going back to the client for the response. Right. Now, this is important to remember because sometimes you think, well, I'm going through the gateway, so any response that comes back through the gateway, I could maybe block responses if they're out of the ordinary or things like that. No, you can't. Right? Those responses are going back to the client unless you put in a different type of gateway. Right? And there are some really interesting and complex architectures like service meshes that kind of do that sort of thing, where they actually don't have a single API gateway. Instead, they have a mesh of these little tiny services that sit there and handle a lot of the same things that an API gateway can do. Right? They form a federation or a mesh to do the similar thing. But the idea here is that the client doesn't need to know the IP address. That they just have the API gateway, and they can send URLs to that. Any questions so far on how this works? And I will change, I see the error in there, so I will change the IP address on the green. So no questions, we all get it? Okay. All right. API gateways are not only limited to internal services. They're also and can be connected to external services. So like in this one here, if I have Wikipedia and I want to get a quote from Wikipedia, I can go to wikipedia.org, hit a port, hit their API, and get a quote from there as well. So as you can see, I can extend my application and my application REST interface without even writing a line of code. I can just let the API gateway know where that external service is and map it to a URI that comes in, and I'm off to the races, which is kind of cool, right? Now, this assumes a lot. It assumes that there is an interface in the external service called getQuote, and that it returns the same type of JSON object coming back out on the other end. But it could be an interesting assumption. So, interesting way that I can architect systems without even writing a line of code. That could be very interesting. All right, so let's take a look at some of the pros. I think we've already mentioned some of them. It simplifies the client interaction. It gives me a single service API to access all the microservices. So that decreases the complexity of my client code, right? Because I can hit the same API. It also means that as I grow and I scale, I can change my microservice architecture on the back end without affecting at all how the client interacts, which is pretty cool, right? As Elle mentioned earlier, it can improve microservice security because I can put the things that I need directly into the gateway, whether it's encryption or whether it's authentication. I only need to authenticate with the gateway and not the individual services behind it. And if I need super duper security underneath the covers, then I could also do authentication between the API gateway and the individual services as well, if you need that as well. All right, so it also limits access from external clients calling the services directly. And it also means that if I have a firewall, I can decrease the number of ports that I need to open up, which gives me a smaller attack vector for my servers and my data center. So I can really use this technique quite successfully for security. I already mentioned a couple times, I'm decoupling. That's always a good thing. The client from the microservice, internal system architecture, and then also cross-cutting concerns, things that I want to implement across all the servers and the way that I talk to the microservices can be implemented in the API gateway. So I only need to implement it once, whether that's security, scaling, whatever techniques I want to put in there, I can put that in the API gateway. And that would keep the services independent of each other and also decrease the amount of code that I'm copying. Okay. Any questions so far? API gateways. You guys got this down pat? Pretty much? Okay. What about, before I hit the next slide, I want you guys to come up with some ideas on what are some of the downsides of using an API gateway. Any ideas? I got time. I can wait.
It's a single point of failure. So when your API gateway goes down, it's catastrophic.
Good one, Aaron. All right. Anything else?
Well, debugging can be difficult sometimes.
Oh, yeah. Debugging can be difficult.
And since it's like another service to maintain and deploy and monitor.
It's another service to maintain, deploy, and monitor. Yep. Anyone else?
Have a simple answer. Isn't it just like over complicating it sometimes? Like making
Yeah.
it over complex in a way.
It is, and this is always a concern that you have to deal with. Is, am I overcomplicating my architecture? Are we using Occam's razor? Right, the simplest solution is probably the best solution. Is this a simple solution? I just added another microservice that I have to maintain. Wouldn't it be better if I just stuck with a monolithic program? So when do you make that decision? What other cons do we have possibly? And then we'll talk about decision making. Anyone else have any other cons?
I guess for me, like it'll be the learning curve for like the spring web flux.
Oh, you are right. The learning curve. Yeah. Yeah. There's more moving parts. The learning curve can be kind of tricky. How do I got another microservice I got to configure and set up. Luckily, we're using something called YAML files, which, all right, YAML files are very temperamental. We'll talk about that. Every space counts in YAML. It also requires, you already mentioned, deployment and orchestration mechanisms to keep them up and running. There's an extra level of indirection, which means it's harder to debug. Right? So it sounds like the cons are pretty bad. So why in the world would I do this? So in what cases would you guys choose a microservice architecture over monolithic? And when would you not?
If you have certain
something that requires high stability, maybe like.
So high stability, you would go with microservice or you go with monolithic?
Probably the microservice using the API gateway.
Okay.
Like a lot of users that required a lot of traffic. I assume
okay,
this.
so scalability for sure.
Yeah, it seems like just keeping the availability up is a very large benefit of microservices because if one thing goes down, it's not the only thing going down. Well, it's the only thing going down. Not like monolithic where if one thing goes down, maybe the whole thing will go down.
Everything goes down, yeah. Well, I still have a single point of failure with an API gateway. If it goes down, I can't talk to it anymore. So that's bad. But I haven't destroyed any long-running jobs that might be running in there. I can just restart the API gateway without affecting any of the call stacks and the other microservices.
Quick
So it's
question.
resilient. Yeah, Ronald.
Oh, sorry. Yeah. Does the single point of failure still break down that way for the federated system?
It does not. The federated systems, and do you guys understand the term federated? No? Okay, so federated means that there's no single service in charge. And what they do is they form a federation, right? Which means that the individual services out there all communicate with each other and no one is in charge and anyone can drop and the federation still works. And you can, with the federated system, you can get all the way down to one instance of the federation running and it will still work. So if I have an API gateway that's federated or a service mesh like Istio is a federated service mesh, then there isn't one controller that's necessarily in charge. And sometimes they pass off control, but most of the time they're totally federated. So when a request comes in, it handles a request or it shoves it off to someone else to do it. And that's kind of the way a federated system works. So they're highly resilient but they're much more complex because now I've got multiple instances of the same microservice running.
So it would mitigate some of these cons, but it still comes with added complexity.
It does. Yep.
Tell me if I'm wrong. So like monolithic though, you're kind of like locked into like the one thing like we would be like using Java or Spring Boot, but with the microservices, you could build it upon different languages, right? It could like
Absolutely. It is a really good way if you're going to bootstrap a Python, a Python script and a C script and a JavaScript or Java application. If I put a REST interface on all of them, I can put an API gateway in the middle and voila, I'm off to the races. Harder to maintain when you have to know 3 or 4 languages.
It's been
Yeah.
useful when we have lots of teams, like if we have 3, 4, 5, 6 teams all working on the same segment of the enterprise. If you build microservices with the API gateway, everybody can be doing their own thing in their own space without everybody stomping on top of each other.
Yep. Yeah, you guys remember from our last class, we talked about that, right? If I have microservices, they can have their own repo. They can be developed independent of each other. It fosters reuse. If you write a really good microservice that can be reused for multiple projects, that's a real good one, right?
and then can't you like implement like a circuit breaker to handle failure? So instead of everything failing, it can kind of, reroute.
Yep, absolutely. And we are going to talk about circuit breaker. I think it's next week. I talk about circuit breaker patterns, right? You can see that these design patterns that we've been talking about really become important, especially when we start talking about microservice design patterns, because you could do things really wrong with this, and you could do things really right with this. So it's important to look at the design patterns and anti-patterns, which say, don't do it this way, right? If you do it this way, it's bad, right? That's a good anti-pattern way of describing the anti-pattern, is doing things a certain way gives you bad results. Right? Okay, so when you guys are in industry, when you're out there and you're slapping together an architecture, it is critical that you understand the pros and the cons to not only the overall architecture, monolithic or microservice, but also looking at the different elements of a microservice architecture and which ones you're going to use. And was it Jonathan or LaShawn? One of you guys said, hey, complexity is not good. And it's not. We should be looking at the simplest solution for what we want. But you also have to take into consideration that these applications live on. And they live on longer than you think. All right, so I should have done a poll for this, but I want you guys to think about this. How many of you have programmed in COBOL? Raise of hands. I know I'm going to see who's Aaron. Doesn't surprise me, Aaron.
Yeah, I'm old.
Aaron, how many active COBOL programmers do you think there are in the world?
Well, fewer
Well-
every day, but they get paid a lot of money.
They get paid a boatload of money. And
Yeah,
how many COBOL programs are still running?
a bunch. I did another language called RPG4,
I remember, yeah, I know RPG.
and it's like there's still millions of lines of that stuff running.
So when you guys architect something, you need to architect something that it may last a really long time. Just like those guys back in the 80s and 70s that put 2 digits for the year, thinking, oh, this code will be replaced before 2000, right? And you guys all remember the Y2K fiasco. It cost billions of dollars of people scouring through code, right? So keep in mind, right, that whatever you're designing and you're architecting is going to last a long time, right? So If it's a monolithic program that you see a path where it could be extended, you may want to start looking at microservice architectures because it's easier to extend a microservice architecture than it is, a monolithic program. Okay, so there's another thing you should be paying attention to. Okay, let's dig right into API gateways with Java, right? With Spring Cloud API Gateway. There are some simple concepts here. You guys can see how the gateway's working here. I've got the client, it sends in a request. The request gets handled by the map. And then I've got something called a predicate. We'll talk about predicates. I've got filters. Then the request goes out to the service and the response comes. And in Spring Cloud Gateway, the responses aren't going back directly to the client. They're actually going back through the gateway so I can post filter and send it back out. This architecture works really well if I want to do that sort of things, but for scalability, this might cause some issues, right? Because now I have a bottleneck in the Spring Cloud Gateway. So just keep that in mind, okay? If I have 1,000 services on the back end and I'm processing 1 million different requests coming in, and I've got hundreds of thousands of clients or tens of thousands of clients, my bottleneck now becomes that Spring Cloud Gateway. So I may want to look at a different option instead. But for what we're doing here, it works out really well, and it does a pretty good job. So let's go through each of the different ways that I configure this, because you're going to have to do this for assignment 2. Okay. All right. So let's take a look at the routes first. Okay, we use YAML. Now, how many of you are not familiar with YAML? Show of hands are not familiar with YAML. Use the hand button, Hamza. You guys have used it. Some of you have used it before. All of you have used it before. Okay. Well, then Hamza and I will just spend some quality time right now going over this. All right. Let's take a look. Okay. YAML. What? First off, quiz. I guess a pop quiz. What does YAML stand for? Anyone?
Yet another something.
Yet another
markup language.
Mark, yeah.
YAML ain't a markup language. That's what YAML stands for. It's like GNU is not Unix. YAML ain't a markup language. Proper English there.
I thought it was yet another markup language, or is that like some kind of inside joke?
That's probably an inside joke. All right. The interesting thing about YAML is it lets me define an object structure very easily without a lot of syntactic sugar, like I normally get with like JSON, right? JSON would be a very easy corollary to YAML. I can do the same sorts of things in JSON and YAML. I can even ask ChatGPT to convert this to JSON, and it can do it really quick, very easily, right? So we're going to learn a little bit about YAML and specifically about defining routes. So it is important when you guys are typing this stuff in, if a YAML plugin is not already put into your IntelliJ, add it. It will help you dramatically. Okay. Spaces mean that whatever, what's the best way to say this? If I have a space on a line, it means that it is a association with the line above it that is not spaced. So for example, here, I have 2 routes. I have routes, and then I have a dash, which says this is going to be an array. And inside that array, I've got some objects in there. And I can see that I have 2 objects in here, Handy and Zippy. Okay, the dash there says this is going to be an array. So if I were to suck this YAML file in as an object, it's going to have an array. Routes is going to be an object that has an array with 2 routes inside it. And each one of those routes is going to have an ID, a URI, predicates, and filters. And then under predicates, I have another dash there. I can see that, oh, this is another array. So predicates ends up being an array with a path in it, and filters has an array with some filter, whatever, filter object, whatever you want to call it. In this case, it's just a string that we could talk about what those mean here in a little bit. So you guys does that make sense? Any questions, Hamza? Since you were the only one brave enough to say that you haven't used it.
It makes sense. Thank you.
Okay. Spaces matter. If you mess up on your spaces, it could take you a long time to figure out, oh, crud, what happened, right? I created another top level object. Routes, it doesn't have the filters in there. What's going on? I've seen this. I've done this myself where my YAML file was messed up and I couldn't figure it out, right? That's why a good plugin to IntelliJ will help you out, right? It'll find the errors for you very quickly. So in this case here, I'm defining the routes for my API gateway. So I give it an ID. I have a URI. This is telling what? This is telling the gateway where to find the service handy, right? I find it at localhost 9100, right? Predicates we'll get to, but the key thing here is that I can define these routes. So just like this one here, I've already beat this one to death, but this one here, right? The directive, well, this is what here I'm stating where I'm going to find this, the handy microservice. Okay. Now, this directive, the URI directive, is not necessary if I'm using service discovery, which I'm going to go over service discovery a little bit on today too. Okay. So, but if you don't have service discovery, then I put the URI in there. So what happens is when I need to get to the handy microservice, I know the IP address and or the host and the port that I'm going after. Very simple. Okay. Now, predicates. In Cloud Spring Gateway, they use the term predicates. Other tools that do similar things like Traffic or Nginx, which can be used as an API gateway, use the concept of path, but it's basically the same concept, right? Predicates basically inside there, I'm going to declare what path is coming in from the client, and if I see this path, then I'm going to route that request to the URI above. So in this case, if it starts with handy, then I am going to route anything that starts with handy / and then no matter how long the string is, that's what that double asterisk means. It means I don't care if it's handy / get quote / whatever. I'm going to take everything. So anything that starts with handy, I am going to route to localhost 9100. All right.
So with in regards to our thing, it would be like the Spring Cloud Gateway would be like the /movies /*, and then it would be like it would forward it to the movie service, and then the movie service would process and return its response. Am I processing this correctly?
That is correct.
Okay.
That is correct. You got it. All right. Now this does headers. This does URLs, cookies, parameters being passed in. So predicates, I can put all sorts of things in there, not just path. I can put lots of different things and redirect that request coming into different services based off of any one of those 4 things there. So I could make it even, hey, if it's movies/search, but I'm searching with multiple regex, I can create a predicate so that that regex goes to a different microservice than just search with one regex. Right. So that's kind of cool, right? That I could do that. Okay. All right. So let's take a look at. I already talked about that, right? The route is considered matched if the aggregate predicate is true, meaning I've already covered all that. All right. So next one is filters. Now, filters are really interesting too, because if I want to strip out heady, let's say I have 2 microservices that are basically the same, except they point to different databases, right? And it's called get quotes. That's my interface to those. So in this case here, if I call zippy get quote, I just want to call get quote as my entry point into that microservice, as my endpoint, right? I just want to call get quote. I don't want to call it zippy get quote. So what the filter does with the strip prefix, and there's a bunch of prefixes we'll go over next week, but there's a bunch of prefixes. What it does here is it strips off the path that I had up before, the handy. It'll strip off that first thing in the path. So what gets passed to handy is localhost 9101 get quotes, not localhost 9101 zippy get quotes. So it's stripping off that first path, right? So there's several different filter types where I can strip off different things and manipulate the URL that's going to the actual microservice. So this gives me another lever inside my API gateway so that I can redirect traffic based off of different things and have maybe the same interface on the microservice side, which makes it much easier to do. I can reuse code in a lot of those cases. Okay. Questions by anyone on filters? You understand the difference between filters and predicates?
That's kind of where my question lies. For something like role-based authentication, where would be what would be the best way to handle that? Would it be in the predicate and the filter, or would you just create a brand new route to kind of handle admin, customers differences?
I would probably handle that in the predicate in the headers, because all your authentication is coming through the headers, right?
Okay. Mm-hmm.
So that's where I'd handle it. And there might be some filters that I can leverage. I have to look through all the list of filters as well, but I would handle it in the predicates.
Thank you.
So I feel like as like the filter, it's like if the request looks like this, then use this route.
And that's the predicate.
That's the predicate.
The filter is going to say, okay, the URL that came in, you've now said use this URI. Now the filter is going to say take that URI that came in and manipulate it to something else before you call the URI.
Okay. Okay. Thank you.
Okay. So the predicate, the predicate goes, I know which microservice I'm going to talk to. I get the URI. The filter then takes the request URI that came in and strips out or changes it however I need to call the microservice itself.
Okay. So the response is after the route's already chosen for the filter. Okay. Thank you.
Now they have in this API gateway, they have post filters as well. So I can do stuff to the responses as well as they're coming back out. Okay. Well, Chad, that's pretty cool. All right. So let's look at, I showed you routes. So there are 2 files to configure the Spring Cloud gateway. There's an application.yaml file and an application path.yaml file. All right. Remember, YAML's our friend. All right, here's the application.yaml file. And you're going to see something here called Eureka. We're going to talk about Eureka in more depth next week, but I'll give you a kind of a highlight of what it's doing. Okay. First, the application.yaml file is going to specify, it's just a configuration file that helps me set up where the gateway is and also where I'm going to use something called a Eureka, which is a discovery service or a registry service. So it's very simple here. I've got my server, I got a port, I've got my Spring that I have there. I'm showing the profiles, and the application is called Gateway. So it's the application, it's my gateway into my application. So very simple. This part, you won't see a lot of change in unless, you know, here I've got Eureka I'm going to have as well there. All right, and we'll go over this in more depth as well as we go forward. For the application path, you should see this is really easy, right? I've got my Spring Cloud Gateway, and here are the routes that I talked about before. So by putting these in, this will automatically, when my application comes up, the gateway will automatically be configured with those specific ports available, or it'll come up with those mappings to those microservices. Now, here's the key. You have to make sure that you launch those microservices on localhost with those port numbers, right? So this is not launching your microservices. This is just configuring the gateway. Important to understand. Okay. You have to make sure that whatever mechanism we're using, that we put the right port numbers in to those individual paths or to those individual microservices. You need to make sure that you have the right ports that match your gateway. Now, in some of the more modern microservice techniques, like with Kubernetes or Docker, they handle a lot of this stuff for you, and they allow you to do port mapping, which is really interesting. Makes it much easier for deploying these microservices. Okay. All right, clear as mud. Clear as mud. All right, let's go on to service registry. Now, you noticed in the configuration I had there, I had hard-coded localhost 9100 and 9101, right? We don't like hard-coded things. That's bad. Having hard-coded things is bad, right? What we would really like, especially if something goes down or I have a port conflict or anything, what I'd really like to see happen is what? When service A, B, or C come up, they tell everyone, they tell someone, especially the API gateway, they say, hey, I'm up, and this is what I do. I'm this service. Well, instead of telling the API gateway directly, we tell a service registry, right? And the job of the service registry is very simple, to just keep a list of services and their IP address and port. And in some cases, I also push into the service registry my endpoints. What is my REST interface that I can use? Okay. So let's see how that works. So if I have a service registry, as a client request comes into the API gateway, the API gateway will do a map request. So it's going to map the request that came in. It goes, hey, wait, I know about this. When they say Zippy, I'm going to say, I need the Zippy service. So then it's going to go to the service registry and say, look up this service. And it says, I know that service. I have the IP address. So then it passes back the IP address. It runs through the filter with that IP address and then sends the request to service B in this case, right? Before any of this happened, service A and B had to register themselves with the service registry. So when they come up, they go, I'm up, I'm available, this is what I can do, right? Then service B, when it finally gets the request, it will process the request and send the response back. In the simplest form, it sends the response back directly to the client. In what we're going to be using, the response goes back to the API gateway and then back to the client. But this is the simplest view of things. Okay. Any questions on how this works? We're okay? So if this were to show up on an exam and you had to draw a picture of this, you guys could all do this, right?
Yes. Memorizing
yes.
the screenshot I just took now.
You just did a screenshot, right? These will be made available afterwards, no problem. You should be able to think through this. All right, API gateway, what does it do? All right, it takes a request, maps it to a microservice. How does it know where the IP address is? It's getting it from the service registry. Okay, got it. Now I can connect, send the request on, comes back to the client. You should be able to think that. This is important to have in the back of your head when you're doing the programming, because when you're trying to debug something, you're like, what in the world is going on? You'll be able to work through what steps you're going through to make this happen, especially if you have your API gateway configured wrong and you're sitting maybe with the debugger on service B and you send a client request in and it never arrives. And you're like going, what is going on? Go back and look at your routing maps, right? Your routes. Okay. All right. What can, did I hit the right button? Oh, yes. All right. So these are the main features of this discovery service. And Eureka has even more than this, but this is a basic discovery service, right? It lets the API gateway find new services that communicate, right? There's no hard coding of ports and host names in those route tables. So that means I can have more flexibility on scaling or where those microservices are run. That can be used for server-side discovery as well. So if I have one service that needs to talk to another service, I can go ask directly. I don't have to go through the API gateway. I can go directly to the service registry. Hey, I need to talk to service B. It'll give you the IP address back, and then you can talk to it. Okay, and then the clients don't need to know where things are. It's the same thing. The clients have no idea what's going on the back end, and they don't need to. So this even gives me one more level of abstraction. All right, what are the downsides of a service registry? What do you think?
What was your question? I'm sorry.
What are the downsides of a service registry?
That is another kind of list to keep up to date.
Yeah, exactly, Hamza. Yet another service that I gotta keep up and healthy, right? There can be at some cases, if they're not implemented well, you can have a service registry that has the wrong information in it. Because I could have service C running, and let's say I'm doing an upgrade, I have another service C that's come up, and which one is it going to go to? I don't know until the registry happens. So there could be some timing issues you got to deal with. You got to be aware of those.
As I guess like could there be like a bottleneck issue as things like scale, like if the services like continues to grow?
Yes, and we've seen this before in really large systems like HPC clusters that had service discovery turned on when you've got 10,000 nodes and hundreds of thousands of services. It becomes a bottleneck with one service registry. So in that case, I would use a load balancer on the front end of the service registry so I can have multiple, or I'd use a federation maybe even. So there's lots of options there. Okay, all right. To wake everyone up, because I know everyone's tired of me talking, let's do a breakout on 1C. I know some of you have already finished, but if you could help others that haven't finished yet, that would be highly beneficial to them and to help them out. Don't do their work for them, Aaron, because I know Aaron's already turned it in. But let's do a breakout. We'll make it 10 minutes, and then we'll go over what assignment 2 looks like. Assignment 2 is not due for, I think, 2 or 3 weeks. And we'll go over that, and I'll explain to you guys on what has to happen to hand in the final assignment for assignment 1. So let me create the breakout rooms. Let me stop the recording, because recording does not like the breakout rooms. So